Hi, I'm Lauren White. In this lesson, we'll talk together about how to prioritize the substituents on a chiral carbon when those substituents begin with the same atoms. All right, so in a previous video, we talked about prioritizing the substituents on a chiral carbon. Larger atomic mass means higher priority. But what if you have two substituents on a chiral carbon that both start with the same atom? Well, essentially, you just go to the next atom in line. There are some special rules when we have double and triple bonds. Specifically, if you have a double bond, you count it as 2 bonds to that atom. If you have a triple bond, you count it as 3 bonds to that atom. Okay, but all that sounds very abstract. Let's actually do some examples to make it more concrete. First, we want to identify our groups in part A. So remember, we start out by only looking at the first atom in line that is directly bonded to the chiral carbon. So our chiral carbon is right here. So we're looking at an oxygen, we're looking at a hydrogen. We are looking at, remember, this is a methyl group, so we're looking at a carbon. And here, we're looking at a CH2 group followed by a CH3 group. So we're looking at this first carbon. Now, you might see the issue. We know that oxygen is going to be higher priority than either carbon. It has a bigger atomic mass. It comes first. But which one comes second? Well, we have a tie. And when we have a tie, we always go to the next atoms out. So our carbon on the left here is bound to just 3 hydrogens. Our carbon on the right, though, is bound to 2 hydrogens and then another carbon. So we can kind of ignore the 2 hydrogens they have in common. Both of them have 2 hydrogens, but that carbon is the higher atomic mass. So our group on the right, our ethyl group, is higher priority. And so we number this substituent number 2. Our methyl group will be number 3, and our hydrogen is last. Great job. Let's do one more. Again, our chiral carbon is right here in the middle, and we start by looking at the atom directly bound to that chiral carbon. So we're looking at a carbon right here, a carbon right here, and a methyl group on the bottom, a 3-way tie. All right, let's think about what is the next atom out. So let's start with the top left up here. We see that we have this central carbon that we're looking at, and it has 1 bond to an oxygen, has another bond to an oxygen. And of course, it would also have an extra hydrogen. So over here, we have 2 oxygens. All right, let's look the top right. We have our central carbon, and it's bound to an oxygen in this hydroxide. And then it's got a double bond to this oxygen. This is where those special rules come in. A double bond to an oxygen counts as 2 bonds to oxygen. So in total, this carbon in the top right of the molecule has 3 bonds to oxygen. And our carbon in our methyl group is only bound to 3 hydrogens, so it can't even compete with the ones on the top. So since the substituent on the top right, our COOH, or carboxylic acid group, has 3 bonds to oxygen, it is the highest priority in this molecule, so we'll number it 1. The one on the top left has 2 alcohol groups, so it has 2 bonds to oxygen, so it's our second priority. Then comes our methyl group, because a carbon is definitely a higher atomic mass unit than a hydrogen. So that's third, and our hydrogen is 4th. Now, you should feel more comfortable assigning the priority to a substituent when the first atom in line is the same in multiple substituents.